In part 1, we are going to make use of this conditional probability that was given. So probability that x given y prime. This is given to us as 50 over 63. And we have the formula for conditional probability. I'm going to apply it here, which means that the probability of x and y prime divided by the probability of y prime. This is equal to 50 over 63. And we do know the value for probability of x and y prime. It is given to us as half. So half divided by the probability of y prime, which is what we are supposed to find, is equal to 50 over 63. And this will help us to find the probability of y prime. Making this a subject, it is 63 over 100. In part 2, we are going to make use of this that is given to us. So let me quote it here, probability of x union y prime. This is given to us as 3 over 4. And we have a formula for union. I'm going to apply it here, which means that the probability of x plus the probability of y prime minus away the probability of x and y prime. Okay, this is going to replace the left-hand side. This is equal to 3 over 4. We are supposed to calculate the probability of x. So I'm going to leave this as it is. The probability of y prime we have calculated in part 1. So the probability of y prime from part 1 is 63 over 100. Minus away the probability of x and y prime. This is half. So this is equal to 3 over 4. This will give us the probability of x to be equal to 31 over 50. To analyze the probability in part 3, I'm going to try to do a quick sketch of the probabilities on a Venn diagram. So on my Venn diagram, I'm going to try sketch this circle here to represent the probability of x. And this circle here, I'm going to make use of it to represent the probability of y. What we are supposed to find is the probability of x and y. So it is this overlapping region here. And if you were to look at this, it is the probability of x and y prime, which means that we are looking at the area that is inside x and outside y at the same time. And that is this region over here. Combining them together, they give me the probability of x. And the probability of x we have found in the previous part, it is 31 over 50. Which means that if I were to observe from here, we can actually immediately quote the area that can help me to find the probability of x and y. Because this can be found by taking the entire circle, entire region of x. So probability of x minus away this green colored region, which will then leave me with this. So the green colored region is probability of x and y prime. Probability of x we have found previously, 31 over 50, and this is given to us by the question as half. So this is equal to 3 over 25. And we are going to make use of this to try prove whether events x and y, they are independent. So for me to prove this, I'm going to take probability of x multiplied by the probability of event y. So probability of x we have found previously, 31 over 50. Probability of y, I'm going to make use of probability of y prime. So I'm going to take 1 minus away the probability of y prime, which is 63 over 100. And this, I will be getting a 1147 over 5,000. And this is not equal to the probability of x and y. And therefore, from this, I can say that x and y, the events x and y, they are not independent.